Hello class. So for today's topic, it is about sequence. Okay, so defining sequence. So sequence, it is defined as an ordered list of numbers. Okay, it's an ordered list written in a specific pattern. Okay, there's a pattern in this ordered list. Okay, and each number in this sequence is called term. Okay, and the position of the term is given by an index n. Okay, so here's an example. We have series. Okay, we have sequence here. So a sub 1 represents the first term. Okay, next a sub 2, that is our second term. A sub 3, the third term, up to a sub n. Okay, so this is the nth term. So usually the nth term corresponds to the general formula of our term. So using this, okay, so a sub n represents the general formula or equation of our term, of the sequence or term. Term, I think term is the most appropriate word. Okay, the general formula of the term. Okay, and so by substituting the n value in our general formula, you can get the corresponding a sub n for each term. Okay, next, so in this sequence, as you can see, each term is separated by what? It is separated by comma. Okay, so if you're going to represent a sequence, especially its term, okay, so you should write comma in between of terms. Okay, so next, here's the classification of our sequence. So we have this increasing sequence. So when you say increasing sequence, each of its term is increasing. So example, we have 1, 2, 3, 4, 5. So it increases. Okay, it is in ascending order. Okay, another example, we can have 1, 2, 2, 3, 3, 4. Okay, so it's still increasing. Okay, by the way, okay, here's the general formula. It is the example. Here's an example of general formula of a equation, or of a sequence rather. Okay, so we have 2 over 1, 5 over 2, 10 over 3, 17 over 4. So each of those term came from this general formula. Okay, if we substitute n by 1, okay, if we replace n by 1, so we can get our first term, okay, which is, the answer is 2, or 2 over 1. Okay, if we replace n by 2, okay, we can get the second term, and the answer will be 5 over 2, or 5 halves. Okay, if we replace n by 3, the answer will be 10 over 3. Okay, this represents our third term. Okay, so on and so forth. Next, so we have also decreasing sequence. And when we say decreasing sequence, each term, okay, each term from the sequence decreases. Okay, example, so we have our first term, which is 10, and its next term is 9. Okay, it decreases. Okay, another example, so we have 5, 4, 4, 3, 3, 2. Okay, next, so we have this monotonic sequence. Okay, so when we say monotonic sequence, okay, given that you have this So you can say that a sequence is monotonic if it is increasing or decreasing throughout. Okay. If you have a sequence and it is increasing, okay, increasing only all throughout, okay, so it is monotonic. If you have a sequence and it is decreasing all throughout, it is also a monotonic sequence. However, if you have this sequence, okay, let's say we have 1 2 3 4 5 4 3 2 1, okay, so if you have this kind of sequence, okay, so this type of sequence or this sequence is not monotonic, because as you can see, it increases and then afterwards it decreases. Okay, it decreases. So again, you can say that a sequence is monotonic if it's either increasing or decreasing throughout. Okay. Next, bounded sequence. So this bounded sequence, it is defined as a sequence having a bounded below and above. Okay. Having a below and above limits. Let's say limit. Okay. So if you have this sequence and then it is bounded below, okay, expect that it is increasing. Okay. And if you have any sequence and it is bounded above, it is decreasing. Okay. Okay, so when we say bounded below, okay, it has a fixed lower limit, okay, or it has a lower limit or minimum value. Okay, and when we say bounded above, it has a fixed upper limit or it has a maximum value. Okay, so in other words, if we say bounded sequence, okay, it has a minimum and maximum value. Okay, it has a bounding, no, below and above. So good example is this one. So having a general formula 1 over n, okay, and if we get each term, okay, if we identify few terms, okay, so we have 1, our first term, 1/2 second term, 1/3 third term, 1/4, 1/5, so and so forth. So by analyzing the behavior of this sequence, no, so it is decreasing, yes, it is bounded below by 0, okay, it is decreasing, it is bounded below by 0. So how come it is bounded below by 0? So bounded below by 0 meaning the minimum value of this sequence is 0. Why? Because if you're going to analyze the behavior of the sequence, it approaches 0. Okay, it approaches 0. So meaning the possible minimum value will be 0. Okay, that's why it is bounded below by 0. Next, bounded above by 1. So it means that the maximum value of this sequence is 1, and as you can see, it is true because in our first term the maximum value is 1. Okay, the value is 1, and it is impossible to have a value that is more than 1. Okay, based on our general formula. Okay, so I have this sample problem, and then let's try to find the first 5 terms of the sequence. Okay, so let's focus here in our example. Okay, so we have n plus 1 over n squared. Okay, and if we're going to evaluate the first 5 terms, okay, of the sequence, so that is n plus 1 over n squared. Okay, evaluating it from n equals to 1 up to 5. Okay, so to do that, okay, so okay, it should be a sub n. Okay, so for our a sub 1, okay, first term, so we replace all n by 1, so we have 1 plus 1 over 1 squared, or simply that is equal to 2. Okay, next a sub 2, we have 2 plus 1 over 2 squared, or simply that is 3 over 4. A sub 3, we have 3 plus 1 over 3 squared equals 4 over 9. Okay, a sub 4, okay, let me write here at the top. So we have 4 plus 1 over 4 squared, and that is 5 over 16. A sub 5, so we have 5 plus 1 over 5 squared, that is equal to 6 over 25. Okay, so the following sequence, or the first 5 sequence, will be this one. Okay, this one. Don't include the ellipses. Okay, since we are asked to find the first 5. Okay, first 5 of the sequence. Okay, again, don't include the ellipses. Okay, don't include that. Okay, so try to answer the second one. Okay, the second example, this one. Okay, try to answer that. Okay, so here is the answer. Actually, here is the answer. So try to recheck it. Try to solve it. Focus on the process, on how you come up with this answer.